memorize a good portion of your polyatomic ions. That is Friday. Okay. That is Friday. So Friday, I'm going to give you 25 polyatomic ions. If you look at slide number 108, the polyatomic ions, a link to that, slide 108. The rest of what we're going to look at today is on slide 109, if you want to get these things on your screen. But these are the polyatomic ions. There's one cation right here, ammonium. Everybody see that one? Mm-hmm. And then a list of anions. And I think we said there were 27 in the list. There's 25 on the quiz. Okay. If you look at the second page of this, you will notice there is a tips for learning the ions. Okay. If you look down here, it explains the rationale behind the ATE and the ATE and the ITE. So there is a little method to the madness. Okay. So an ATE has more oxygens than an ITE. For example, sulfite has 3 oxygens and sulfate has 4. Okay. And there's the hypo and per prefixes. Those have an actual meaning to them. Okay. So read through that. I would read through that before I started memorizing, or if I haven't already started, great. But read through that is the next thing to do before you continue with this process, because that'll help you sort out these things a little bit. Okay. The only way I know how to do this, if you come up with a better way, knock yourself out. But the only way I know how to do it, and the only way I've ever seen anybody be successful, is flashcards. Okay. And I'm old school partial of the handheld flashcards, little Quizlet things. I mean, that's okay, but handheld flashcards is something about putting it in your hand. It just makes a difference. Okay. So good handheld flashcards with the name on one side, the formula on the other side. The quiz is formatted as to where I will give you the name and you give me the formula. Okay. That is Friday. If you wait till Thursday night to do this, it is not going to go well. Okay. Trying to memorize all of that in one night, not going to work. Okay. Not going to work. So hopefully you've already started. If you haven't, you've got Tuesday night, Wednesday night, Thursday night. That's 9 per night. So you're still in good shape if you just start tonight. Okay. If you wait till tomorrow night, you got 13 one night, 14 the next. Now it's starting to get pretty rough. If you wait till Thursday night, you got to do all 27 in the same night. That's not going to happen. Okay. So if you start tonight, you're still in decent shape. 9 per night. If you started last night, you could do about 5 or 6 a night, which has been easier. But last night's gone. You get it back.
Ellie, you know all of them already, right? Close. Yeah, you're close.
Good.
Yeah.
I know one.
I'm so proud of you.
Which one? Cyanide.
What is
You're
it?
one?
I know one.
What I'm gonna do, I'm
What
gonna
is cyanide? Always the first one everybody learns. Poison. Y'all just heard of it before?
Yeah.
Sounds cool.
Yeah.
I'm gonna get last place.
All right.
Imagine, do you think they can poison? Or just sigh?
I have an idea. What
You like
if
the
the first 20 questions are normal questions for class 5 or
Let's go for cyanide.
Right.
That's a good idea.
Call me Ive. Like a tag. Think of nicknames.
All right, here we go.
It's Ive.
Okay, so here's what we're doing today. We're going to learn to write the formulas of ionic compounds. Okay. Friday, I think it was, we wrote definitions. Friday, definitions of a couple of different types of compounds. We had ionics, binary covalent, acids, organics. Is that right? Polyatomics. Okay. So today is ionics. Now, the first thing we got to be able to do to be successful on the test next week is we have to be able to identify the type of compound that we're looking at. What you're going to get on the test next week is a random list of names, okay, that you're going to write the formula for it. The first thing you have to be able to do is determine what type of compound you're looking at. So you go to number 1 on the test, you're going to read the name, and you're going to first question is, what type is this? Because it's got a different system or process for each of the types. So you've got to know which one you're looking at. The first, so how do we identify an ionic compound? It's going to contain ammonium or any metal. This is kind of actually rare to have an ammonia, but it's a possibility. We'll see one example later. But a metal is what we're mostly looking for. It's going to start off with a metal or ammonium. This being one of those polyatomics, right?
How do we make mustard gas?
I used to know, I don't remember. But it's not too hard to make. Don't need to make it. I probably wouldn't even Google it. Just because it's gonna, the NSA is gonna know that you Googled it.
So that's why you can turn off the camera till.
And then the FBI and other people are gonna know that you Googled it. I doubt they would care too much, probably, considering, teenagers, whatever, but they're gonna know it. Thank you, sir.
A little off topic, kind of on topic. Have you seen those videos on TikTok where they like clean a toilet with a bunch of different chemicals, like of all types, and
Kills you.
people, they're like, it's gonna kill you. Have you seen those? Okay. 'Cause-
That's legitimate. What happens is it generates chlorine gas.
Yeah, it's not mustard gas.
It's chlorine, straight chlorine. If you mix bleach with something else, it will break down the hypochlorite ion, which is on your list, right? Hypochlorite.
Let's go.
That's what bleach is, a solution of sodium hypochlorite. If the hypochlorite gets decomposed and the chlorine gas releases, and it's the perfect situation, or perfect, I don't look at it. You pour those two things in a toilet bowl and you're swirling it, right? Which speeds up, as we'll learn next spring, makes reactions happen faster. And then you're also, the gases are going where, right there. So you, about a breath or two, there you go. Burns your lungs out, not a good way to go. Chlorine was the first chemical weapon that the Germans developed in World War I, before mustard gas. Chlorine, pure chlorine gas.
But like, what's the difference between the chlorine and the bullets?
The chlorine you put in your pool, it's not much. It dissipates very slowly.
So like,
Basically, put bleach in your pool, basically.
alright, so it's like more diluted.
No, it's actually quite strong. It's just bleach, it's not in the chlorine form. So you put a big one of those tablets.
Right.
Tablets, right? And that's basically solid bleach.
Right.
Okay? You just drop it in the water and it
But
slowly
bleach is
dissolves. And as it chemically reacts with all the germs and the bacteria and stuff in the pool, it's killing it. And then it sort of eventually decomposes and dissipates because you have to keep adding, right? But it dissipates so slowly that the chlorine
You're
is
still
very
kicking,
lot.
Julia.
at a
It's-
high
I don't think it's
concentration.
Everything's slowly killing you.
It's
As
such a
time
small
progresses, you're
amount.
slowly dying.
It's a matter of molar concentration, which we'll learn about in a few months.
So the tablet you put in your pool is bleach,
Pretty much, yeah.
but bleach is chlorine.
What did you just
Well,
say?
chlorine is bleach.
Contains chlorine atoms bound up in a molecule called hypochlorite.
I don't know about a girlfriend, if you were a boyfriend.
Itself, not a gas,
Yeah.
but when it reacts
She
with
said
other
yes.
things,
No, I was gonna say.
the hypochlorite ion breaks down
Yeah.
to
I was in there, I
oxygen,
get that.
chlorine, pure chlorine then is gas. So it gets released as gas, which you can inhale it in high enough quantities, it will kill you. But as slowly as it's being released from a swimming pool, that's not enough chlorine, plus you're out in the open air anyway, right? So the concentration of chlorine gas in the air around your swimming pool is basically zero,
So like in World War I, what do they use chlorine gas for?
killing people.
Like, do they like travel in a room? It was like,
No, they shot it at them in canisters. And it busted. Trench warfare stuff.
oh, that's
So I can't shoot you because you're hiding in a ditch, right?
but I
But if I lob a canister of chlorine of some kind of poisonous gas into the ditch and it breaks open and then the ditch fills with poisonous gas, I got you.
oh, that's pretty cool.
Until the wind shifts and it blows back this way and kills me.
Oh,
Just
That,
wait
that was
till
the
there's
problem.
no wind.
That's the problem with chemical warfare is when you're fighting close up, like trench warfare, it's the wind's blowing the wrong way, it'll have the opposite.
Usually, if you plan to use chemical warfare, you have like the gas mask.
Usually, but not everybody gets the message.
That is true.
It was 1940.
wait, did they not have grenades back then? Did they not have like grenades?
Somewhat, they weren't, yeah, somewhat.
But chlorine gas was more popular. They throw it like,
Well, it was, I mean, they used it, it was not as popular as just machine guns.
That's like
Even then,
They
it's
used
better.
it. The biggest killer in World War One was machine gun, had just been. It took them a while to understand that you can't, the old charge across the field method of warfare that had been going on for hundreds and hundreds of years was immediately out of date when they invented machine guns. And it took them a while to figure that out, which it seems to me, I've always found that interesting. It seemed to me it would take about 5 minutes to figure that out. Like when the first wave went across no man's land and got completely massacred by 3 guys with a machine gun. Like, how did the second wave not understand? Like, if I'm the commander of wave 2, I'm gonna, hey, time out, guys. Something's not right, you know? Because, you know, in all the previous wars, we sent 50 people over the hill and 40 of them made it. We just sent 50 people over and 50 people didn't get 20 feet, they're all dead. Next 50 up, like, you know?
they'll run faster.
Like I was at a battlefield last summer, 2 summers ago, in Antietam, Pennsylvania, Marist or something. There's a famous bridge where the Union Army was trying to cross this bridge. There was a Confederate group of sharpshooters on a hill above them. And they killed hundreds and hundreds, literally piled the bridge up. We couldn't walk across the bridge for the dead bodies. They literally just piled the bridge up with bodies. And if you're standing there and looking at the hill, like, and they ended up firing the general that sent them across the bridge and all this other stuff. It was complete idiocy. Like, there's nobody in their right mind. If you go there today and look, the bridge is still there, everything's still there. You can look and you can be like, there's no way that if you put people on top of that hill right there who know how to shoot, that you could ever cross this bridge. Like, it would be impossible. But yet they sent hundreds and hundreds of people to their death on this bridge. You know, go. Everybody's dead. Next up, go. You know, like, how'd they get them to go? Like, that's the most amazing thing to me was how did you, after about an hour of that, the fact that they still, I mean, nobody like you know, just go like, no, I ain't going. It's not gonna work out. And finally, some guy in the back, Colonel So-and-so, took some of his men, went a mile downstream, half a mile downstream, crossed the river, went around behind the people, and did it. Like, it took y'all 3 hours to figure it out. Hundreds and hundreds of people died for no reason. And they did fire the general, but.
Well, maybe like the general thought process was like, maybe if I can like stand enough over, like they'll run out of ammo.
If you stand there, if you ever go there, and you stand there, you'll realize that it was the stupidest thing ever. Like, there's no way that anybody in their right mind could stand there and think, yeah, I think we can get across this bridge with people lined up right there with all with weapons.
Maybe they just need a really fast guy to get through.
No way.
They would
faster
seem like
than
a
a
track
bullet.
star.
Ain't nobody faster than a bullet.
The Flash.
Anyway,
You know?
I can't remember the name of the bridge, but you can look it up. There's a bridge in Antietam.
That's just something.
Bloodiest day in American history. Was it 20,000 people died? One day. Wow, dude. Bad news. All right, let's see. Here we go. Names and form of the sonic compounds. Episode 4. We have a step-by-step process. So the first thing we have to do is recognize, for example, here's a list of names. If we notice there's magnesium, germanium, nickel, molybdenum, copper, lithium, calcium, barium, these are all metals. How do I know that? If all I am is a lowly high school chemistry student and all I have is a periodic table, how do I know those are metals?
You're at next page.
On the left-hand side of the step line, right? Okay, all right. So I recognize those are ionic compounds. So what am I going to do? I'm going to follow this set of steps right here. Okay, so this is what you got to learn today. Step number one, we're going to write the symbol and oxidation state of the cation. That's the positive part of it, correct? So let's do number one, magnesium nitride. Here we go. Magnesium is the cation. They're always written cation, anion in that order. Okay. So magnesium, if we need its oxidation state or its charge, it doesn't really matter either way. Okay, because that's mathematically the same thing. So how am I going to know magnesium's oxidation state? We'll look at this thing called the periodic table, right? Okay, and I'm going to see that it's in the second group. And everybody in the second group is +2. Everybody in the first group is +1. Okay, the rest of the metals have multiple possibilities, and we'll talk about that in the next example. Okay, so this is +2. Step number two, I'm going to write the symbol and oxidation state of the anion. This is nitride. Now, here's where people get confused. Okay, is there is nothing on the periodic table called nitride. There is nitrogen, right? On your polyatomic ion list, there is nitrite and nitrate. The periodic table says nitrogen. So what is nitride? Nitride is the negative anion of nitrogen. So if it ends in IDE, two exceptions, hang on. If it ends in IDE, that's a monatomic anion. Fancy way of saying it, somewhere on the right-hand side of the periodic table. The exceptions to that are hydroxide and cyanide. Every other polyatomic ion ends in ATE or ITE, except hydroxide and cyanide. So you just got to remember, hydroxide and cyanide are polyatomic. All the other IDEs are off the right-hand side of the periodic table. So nitride is nitrogen. It's a capital N. And it's in the, this is 0, the halogens are -1, the oxygens are -2, nitrogen would be what? -3, right? Okay. Back over those numbers, yep.
Why is it -3?
Well, if we drew out its orbital diagram, we would see that it needed 3 more electrons to be stable.
Okay.
That's the long way to do it. I don't advise that at this point. It's going to be a much bigger hurry than that. The easy way to do it is to look at the periodic table and go, noble gases are 0, halogens are -1, oxygen group's -2, nitrogen group -3. Count it that way. Okay, now, the atoms are going to bond in a ratio, particular ratio with each other. We know what a ratio means, right? Okay. The ratio that they bond in is going to be opposite the ratio of their charges or oxidation numbers or oxidation state, whatever word you want to use. Okay. So the ratio here is 2 to 3, correct? So that means they're going to bond in a 3 to 2. Now the shortcut little cheat thing we call it here is the crisscross method. We're just going to take those two numbers and switch them and ignore all the signs. Switch them. That's going to give us the subscripts. So the final answer is Mg3N2. So the charges and oxidation states are superscripts. The number of each element is a subscript. The final answer should include only subscripts. The only thing, final answer for the test next week, that will include superscripts are the polyatomic ions. Everything else should not have any. So that is the formula for magnesium nitride. Now, yep,
Why did it get from positive 3 when it came down to negative?
we're just, basically it's an absolute value ratio.
Okay.
And the numbers at the bottom are the number of each element, so a negative number would make this sense. If you look at the next, what does that say? Germanium something sulfate? What does that say? Sulfide? Anyway, all right. So germanium, what's that next to germanium? Roman numeral, right? Okay, all right. So the D in P block metals have multiple stable ions, multiple oxidation states. So the name of the compound has to tell you which oxidation state that metal has at that moment. Okay, so this is germanium 4. Okay, it's telling us that. All right. The exceptions to that Roman numeral stuff are that, if you remember from the other day, that silver is always +1, zinc and cadmium are always +2, and aluminum is always +3. Okay, they will not give you Roman numerals for those 4 elements. You're expected to know that silver's a 1, zinc and cadmium are 2, and aluminum is 3. The rest of the D and P block metal should have a Roman numeral in parentheses right after their name. Which means we've got to know our Roman numerals, which we finally had somebody be honest this morning, because for the last 10 years I've asked the following questions. Does everybody know their Roman numerals?
No.
Honesty? Okay. And everybody always goes yes. And then I give the test and I find out that about 70% of the people don't have a clue what a Roman numeral is.
I don't know.
But nobody wants to admit it. So y'all are nice, honest people. That's good.
I know what,
I
I know what Bob is. I know what
B. All right, here we go.
6.
Roman numerals 1 through 10 right here. Okay.
All right. It's right there.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, pretty self-explanatory, right?
Right.
B is a 5, and an IV means 1 less than 5, so that's 4, right? Okay. 1 more than 5, BI means 1 more than 5 is 6, okay? 7, 8, X is 10, IX is 1 less than 10, which would be 9. That's how Romans counted. Okay. It's a little weird and a little cumbersome, and that's why we adopted Arabic numbers, because we found it inside everybody.
So it's 4.
Good job, Felix.
Just making sure. He asked, and I said 4.
I learned in 3rd grade.
So we were wrong.
I was back in October. My mother made me learn.
So like your Bob taught you?
From, Percy
So
Jackson.
your Bob taught you?
If she wasn't teaching me, I was teaching myself.
Oh.
I learned from Percy Jackson.
So, uranium 4, what is sulfide? That's sulfur, which is in the same group as oxygen, so it's a -2. Okay? So we're going to crisscross these numbers. And then we've got to make sure they're in the simplest ratio. That says that up here somewhere. Number 4, reduce the subscripts to the simplest ratio. Don't write the ones. So a 2 to 4 ratio simplifies to what? It's like simplifying fractions, right? 1 to 2. So the final answer is GES2. Like we did the other day, I remember we wrote some stuff on like kindergarten paper, you know, we wrote it on the board. All right. Make sure your uppercase, lowercase letters are distinct. Make sure your subscripts are subscripted. Okay. All right. Yep.
Well, the 4, I'm sure we're not. I just answered my own question.
Good deal. All right. Nickel 2 phosphide. Nickel plus 2 phosphide is P minus 3. Crisscross the numbers. Ni3P2. Let's see how that works. Okay. All right. We'll switch handouts here. I'm going to do some with some polyatomic ions. What time are we out of here?
25.
45. Yeah, let's do some polyatomic ions.
24.
Jeez, y'all be so.
From 2 to 4 is what is it?
Okay, if you look on this worksheet we just looked at, if you scroll down to the bottom, there's the answers to the rest of them. Okay, we're gonna go over this one right quick.
Because 2 and 4 is 1, but you don't write the ones, so it's just G, S, 2.
Oh, no.
You simplify it.
Okay, so if we look at this list right here, how do we know they're ionic? Yep, let's all start with a metal, except this one is ammonium, which is also makes it ionic, correct? All right, now, go down through here, take 30 seconds, and tell me which ones are, which of the anions or cations, or put it this way, which of these compounds contain a polyatomic ion? Let's find those right quick. We're looking for cyanide, hydroxide, or something that ends in ite or ate. All right, so check mark everybody that contains a polyatomic ion. Acetate, phosphate, hydroxide, carbonate, chlorate, chromate, ammonium, hydroxide, sulfate, cyanide. So all of those contain polyatomic ions. All right, so let's work on these because these look a little different. Same rules apply. So cation first, lithium. Lithium +1 because it's in the first group. Acetate, at this point, you can still look at the list, okay? But by Friday, you got to know that that would be C2H3O2 -1. Acetate is right there.
Yeah, I remember that on Friday, so it was just like, what is acetate? C. Thanks.
All right, then we're going to do the same thing we did a minute ago. We're going to crisscross these numbers. So these are bonding in a 1-to-1 ratio. So this ends up being lithium acetate. Bonded 1-to-1. There's 1 lithium for every 1 acetate.
Wait, so did you pull the +1 at the beginning from lithium?
It's in the first group.
Yeah.
So the quiz is over the substrate, right? Is the quiz only gonna be subscript?
This Friday,
Mhm.
there'll be subscripts and superscripts. If you're just writing the polyatomic ion, it's got subscripts and
I'm so
This is,
confused.
this is stuff for the test.
this is not for the quiz Friday, this is for the
This is
test.
test.
But
Oh,
nothing
okay.
changed, you just added LI.
Chart right there.
What?
So you guys all of that.
That was it.
Okay, so that's it
All
for
the
the quiz
numbers
Friday,
are-
so all of this is gonna be on the test next
Yes.
Friday.
Because you crossed it and it's a 1-to-1 ratio.
Okay.
So you just, you don't write one.
All the numbers are the same.
What we did earlier, that's just memorizing all the.
You mean from here to here?
All that memorized.
Yeah, 'cause it's 1-to-1, so that's-
So it feels like-
Do the next, hold that thought and do the next.
Superscript is number like your negative or
Alright.
positive at the top.
Everybody watch the next.
Yes.
Superscript is your positive number.
Iron 2 phosphate
And so,
PO3
no, look.
Fe
PO4.
plus
This
2.
is the top line, number of each element up front.
You can feel it.
Right now.
No. Superscript.
Yes.
Yes.
You said the opposite.
No, I didn't.
She literally said superscript is at the top.
Iron 2, all right, and then phosphate, PO4 minus 3. Are you good with that?
Yes.
And we're gonna switch them, but now we're gonna have to do a little trick here, okay? This 2 goes here, this 3 goes here. All right, but it's 3 irons and 2 phosphates. So here's how we write that. Fe3, the phosphate has to go in parentheses, 2 goes right there,
What's the parentheses for?
because it means there are 2 phosphates.
Okay.
Because this whole thing is phosphate,
Okay.
so then there's 2 of each of these. 3 irons, there's 3 irons and 2 phosphates. All right, so when you crisscross a number down to a polyatomic ion, if that number is not a 1, you have to put parentheses around that polyatomic ion. If it's a 1, then you don't. Okay, here we brought down a 1, right? No parentheses. Here we brought down a number that's not 1, we put in parentheses. This number doesn't change. There's a million ways to do this wrong. People end up putting the 2 here instead of the 4. People put 8 right here. People put 6 right here. Added, multiplied, replaced. All that's wrong, okay? Parentheses with 2.
And that's only for, the parentheses only apply to the polyatomic ions?
Yes, only if you have a polyatomic. If this is a monatomic ion, then no parentheses needed, like, well, whatever previous answer we had.
Are the 4 and the 2 on the same level, or is one of them?
The 2, they can be, but the 2 is kind of like a subscripted subscript.
Okay, so it's
It's kind of a little smaller, a little lower down, just to make sure you kind of distinguish it. But you know, don't have to. All right, let's do 27, 28 before we get out of here. I think that's where we left off this morning. All right, beryllium hydroxide, that's Be2 plus. Hydroxide is OH1 minus.
So it would be
Okay, so the 1 goes here, the 2 goes there. Do I need a parentheses?
yes.
Yep, because 2 is not a 1. So, there we go. Beryllium hydroxide. All right, last one for today, zinc carbonate. Zinc is one of those we've got to remember. It's a 2 plus.
Right.
Carbonate is CO3 2 minus.
Right.
By Friday, we got to remember that. Okay. This 2 goes here and this 2 goes there. 2 to 2 bonding ratio simplifies to what? 1 to 1. So if it's 1 to 1, there's no need for parentheses. Okay. So the final answer is zinc carbonate. Okay. real quick, just look here at these two handouts. What you need to do tonight, okay, on top of, we got a quiz Friday on the polyatomics, which hopefully you've already started working on, so therefore you work on this too, or not, you're just gonna get more and more behind. These two handouts that we looked at right here have the answers at the bottom, okay? So please finish the rest of these names to formulas. We'll talk formula to name tomorrow, but finish the rest of these named to formula and finish the rest of these named to formula. If you scroll down, they have the answers also, okay? So work those out and check yourself. Okay? Flashcards, flashcards, flashcards.
But just to like be crystal clear, on Friday, all I need to know is the polyatomic items, the formula and the name.
So like, how will it be set up? Will you give us the name of the computer?
25 names, you give me 25 more.
We make a deal of like 20 questions, be normal, and 5 be bonus.
What about
Bonus
20?
at all?
So 90.
Can we just do 2 bonus questions?
Just like,
I said we could just do like all 27 of them, but 2 of them will be bonus.
Oh, if I lose for a handout.